Hello everyone. Now we are going to see about the fourth dimensional arithmetic progression. So before coming here, I just wanted to introduce small interesting topic, how this fourth dimensional going to be utilized. So as we see that third dimension is having a first phase, and behind that is like a front phase is F1 and back phase is F2. Imagine about that we done the third dimensional arithmetic progression. Now we can take a look at this. Imagine that we have a we have a several galaxies, right? So in each galaxy we have a star system. So take an example, this star system like solar system, everything is inside the one of the galaxy. Another galaxy also has other galaxies like Andromeda galaxy, and then other type of and any other galaxy we have a solar system. So imagine this is like a three-dimensional one from each other separate space. But if you see like in time and space, each will distance between 10 million light years from one star system to another star system in each galaxies. So imagine about this problem. Imagine about like a fourth dimension is exist like this. So how should I say like this? The star system will having this cubical structure, so which is 10 million light years far away from each other. So this is how the real world calculation will be impactful for fourth dimensional arithmetic progression. So coming to our thing. So as you see that we have done it. So this is like a one single cube. So this whole structure is single cube. If I remove this calculation, this whole structure is one cube. This two. So this front face and back face is a single column. This is a single cube. This is only a single cube. It's one here. Now in our problem statement for dimension, we have a several cubes. So imagine the same thing. I'm taking the same face one as one cube, and then I'm creating another cube. So you imagine now this texture with this. You can compare with this texture like this. So this is like an interconnector. If I want, I can show you the fourth dimensional how it. So this is how the complex structure of the fourth dimension will work. So as you see, it looks like very complicated. That's why I bring into your as a human we can be able to imagine about third dimension. So it is like a three-dimension interconnected with fourth 90-degree perpendicular axis tries to become a fourth dimension. That is what they are saying mostly. So coming to this picture. So this is like this picture. If you imagine this picture with that with this image, you can able to compare and correlate. So coming to our problem statement, uh, yeah, I brought it here. See, we have how many cubes we have? We have three cubes. So each cube difference value is 20. So as usual, the row column between the numbers is 1 and row between the difference is uniquely 7, and phases 1 to phase 2 difference is always 5, and then the each cube value is 20. So in this cube too, this value is 20 and this one is 20. So this is a similar differences. Okay, so these are the difference values common across each cube. each cube. This criteria is satisfies. So we have the first number is 7 and last number is not 20 here. So I taken another example. Here first number is similarly 77 and last number is last cube's last value. So last cube last value is 60. So here we have 60 is our last number value and how many rows we have? We have two rows for each and we have two columns for each and we have two phases. Each cube contains two phases, but how many cubes we have? We have three cubes. So here it is the formula comes. Surprise. Now here I am introducing another variable is nothing but cube. So the formula here, how many rows we have? Two rows into two columns into two phases into how many cubes we have? Three cubes whole divided by two into first number is 7 and this last number is 6. If you see this value is 804 we are resulting. We can, as we know already, this value is 108. From this formula we found 108. Now here you come calculate each values. Now if we add this to number 268, now if I add these numbers, I'll get 4, 8. Now if I add these numbers totally, here you see 804. Hence we cross verify the sum of values is coming correctly. So that's the beauty of this fourth dimensional arithmetic progression. Thank you for watching this video.